Hello everyone, my name is Jose de Jesus Alarcon. I'm going to be doing the robotics and embedded systems objectives. So let's go ahead and move forward. Design and implement and complete robotic and embedded system solutions that apply to real world situations. So here I ended up using my SIP project, okay? Now this SIP project is called Motion Saver, which utilizes the M5 stick to motion sensor technology to monitor leg movements. This system itself attaches to the leg of an amputee. It's designed to prevent pressure sores by setting a threshold for the movement. If the threshold is met, it will send notifications via a IFTT application. Now, I think this project fits with the objective because it directly addresses real world issues, to prevent issue of pressure sores in amputees. This system is designed and implements involves using embedded systems and robotics principles to create a practical solution for a genuine problem. Now let's move on down to the next one, and it's a traffic light system. The traffic light system, which then primarily focuses on creating an effective traffic management solution. It involves in designing and implementing a system of traffic lights that would dynamic adjust based on traffic flow, optimizing traffic patterns. This system utilizes embedded control to detect vehicles presence and adjust signal timings accordingly. This project I think aligns with the objective as well because you are addressing the real world issues of traffic congestion and offering a practical solution through embedded system design. Now let's move on to the next one here. Excuse me. Here we have the objective 2, which is implement a simple microprocessor using digital logic design. Now here I am using the Larson Scanner project, which I think in my ability implemented a simple microprocessor, which I ended up using a digital logic design principle. This inspired by the iconic eye of, if anybody's seen the TV series Knight Rider. This project would then require the creation of the LED pattern to simultaneously move back and forth. I design a digital logic circuit that precisely controls the sequence of the LED illuminations. But by using digital logic designs for LED control and pattern sequencing, a fundamental skill in the embedded systems, this project I think aligns with the objective 2 because you're using a microprocessor which would then utilize digital logic designs and principles, which would then by crafting the digital logic circuitry which governs the LED patterns motion. Now let's move on to the next one for objective 2. Would be the traffic light system. Now this traffic light project implements a straightforward microprocessor using digital logic design techniques. Now this project it involves the creation of a digital logic circuit. The operation of the traffic lights at an intersection. This is developed by the digital logic circuitry, which would then govern the operation of the traffic lights and pedestrian signals. You can see it over here on the picture shortly. But this project serves as a testament to my own skills by creating a microprocessor-based system that replicates real-world functionalities. Alright, let's move on now to objective 3. I ended up using my SIP project again, Motion Saver. That's what it's called. And this Motion Saver, I think it showcases my embedded system design skill, which then uses components and microcontrollers by utilizing the M5 stick with the built-in IMU, right? Where you can see right here X, Y, and then Z. address the specific needs of PTs by setting a pressure threshold to prevent pressure sores. My design would then involve extensive schematic design, which would design and layout to create a compact and efficient system that could easily attach to the amputee's leg. Moving down here is a 7-segment display. Now in this display, I was able to demonstrate my proficiency in embedded system design. This project involved creating an interactive 7-segment display number counter, counting from 0 to 9. I displayed each number on the 7-segment display. I selected and utilized an Arduino microcontroller, designed a functional circuit and the aspects of the electromagnetic compatibility in managing electrical signals. Okay. While currently at looking at this, I was able to lay the foundations of the potential manufacturing considerations of my comprehensive embedded system design skills. Yes. In Objective 4, apply knowledge of transducers, actuators, and simultaneously hardware and software development. This project here is develops deep dive into transducers, actuators, and creating a highly responsive system. This external interrupts, I think, were integrated into an embedded system, which would then enable processing of physical inputs. Simple button served as a transducer right here, which would then transduce translating electrical signals that would trigger the software interrupts. These interrupts initiated functions such as LED illumination and buzzer activation, which I would showcase the hardware and software coordination in the embedded system. Now moving on forward, the simple assignment. Here the simple assignment underscored my skills in putting together the hardware and the software by the design and digital version of the classic memory game. I not only incorporated the transducers for feedback, but I was able to harness the simultaneous hardware and software development. Players would then interact with the physical button, which acted as transducers, while the software component managed the game logic. The hands-on experience of my ability to apply comprehensive knowledge of transducers and actuators with the software development to create the engaging of embedded system. Now moving on to 5. Design and analyze real-time embedded systems, digital logic, processing, and high-speed digital system. Now in this project, I was able to utilize the AVR microcontroller, which would control a DC motor, which would then I would use the L293 motor drive, which I would see the digital pins and establish the logical conditions to govern the motor's direction and speed. I then in here would demonstrate the advanced digital logic design when I crafted, and I was able to sequence a motor operation that would then encompass forward, reverse, as well as pause for 5 seconds. The project would then lie in its signals and process compatibilities within the embedded system. I think I manipulated the digital signals to make critical decisions and precisely control the motor with the AVR microcontroller. This process of application of which would then varies the algorithms and logical operations to achieve the desired motor behavior. In summary of this motor control, I think this project serves as an excellent example of real-time embedded system design. This was also encompassed by I would also encompass by the advanced digital logic design, the signal processing, and precise the high-speed motor control. The next one down here was the robot behavior. I was able to design and analyze real-time embedded system, focusing on advanced digital logic design and signal processing, using with a high-speed digital system. This project itself, I was able to evolve the Arduino base system. Here I was able to use 2 DC motors, dials, resistors, transistors, and what I ended up doing was I ended up implementing user operated potentiometers for the manual motor speed. I ended up doing the showcase of advanced digital logic design principles. Additionally, I explored signal processing aspects, highlighting the integration of hardware and software, which would then achieve precise motor control. Okay, now the next one here is 6, algorithms and methods enabling autonomy in a mobile robot. Now in this robot navigation, I implemented and I was able to evaluate algorithms and methods that present autonomy upon a mobile robot, utilizing the Arduino system, including the components like the L293 motor drive, the ultrasonic sensor, and the Arduino 328 board. This project, I was able to use my dedication to achieve robot autonomy through the hardware and the software design. I was able to integrate the 293 motor drive, the sensor to empower the robot with obstacle avoidance compatibilities, which I was able to enable it to navigate while avoiding obstacles. I would then refine the algorithms and evaluate the robot's performance. And obviously in a bunch of scenarios, I was able to use my skills in autonomous behaviors. This project, I think, would perfectly align with the objective of implementing and evaluating the algorithms and the methods that empower the autonomy in a mobile robot. So my next one down is a robot with a servo motor. So here I was able to enhance my iteration, which introduced a servo motor to elevate the obstacle detection compatibilities. I would then mount the sensor on top of the servo motor. The robot would then gain a sweeping vision. It would then expand sensor range for dynamic navigation. I think this project would significantly advance autonomous robot behavior through innovative algorithms, the sensor integration, the servo-based navigation, which would then reaffirm my own commitment to develop autonomous systems. If we do have a little time, I'm going to show you a demonstration here. I would like to thank my SME Professor Matt Prater for guiding me through these robotic courses, because he's part of my he's my SME for robotics and embedded system. But here you go. I do have you could tell the servo motor itself is turning left and right, finding a clearer path to go see and view. I ended up just moving it because of my carpet and the mat was in the way, but you'll see it right here too. Stops at 20 centimeters and it continues forward.